second major idea, though, of the last decade has been the notion that computer networks were not only needed but were valuable, and they are gradually coming into fruition.
The problem is much like small civilizations or small cities trying to develop separately and not having any way of sharing what they learn with other groups. And if that continues to happen, you don't have a civilization. So that the necessity was to provide a mechanism so that what was learned one place could be transferred effectively and directly to other places without redoing it all and learning it all over again at each place. The problems were not in the computers, we found out. The computers could talk to one another, even though they were very different. The problem that we found was that the communications was inadequate.
And ideally, what we wanted to do was to use a common carrier offering. Unfortunately, there was no wideband switched common carrier offering at the time. The underlying concept of that network would have to embody the efficient utilization of communication resources, as well as to provide a system which was both reliable, error-free, and provide the high bandwidth needed for interactive use of those resources. This means that users sitting at a terminal would be able to hit a key and see a response virtually instantly, almost as if that computer, wherever it were, looked like it was in the same room. A simple way to interconnect computers and to form such a network is to place wideband leased circuits, in the case of the Arpanet 50 kilobit per second circuits, between each of the computers, and then to interconnect each of the computers to each other to form a fully connected network. As more sites come onto the network, the requirement is then to connect that site to every other one, which means that the extension of the network is just not a graceful thing. And so this naturally leads to the concept of a store and forward technique in order to cut down on the expense of building such a network. And so let's erase these lines over here to leave ourselves for the moment with a loop network which can be extended. And in this type of network, this computer, for example, would talk to this computer not by sending it a message directly, since there is no circuit, but sending a message first to this computer, which would then store it and forward it onto this computer, thereby acting as a relay. In order to have a reliable network of this sort, each of the individual computers must be sufficiently reliable to maintain the kind of communications that's needed. But unfortunately, most computer installations are just not reliable enough, and this leads to the notion of a small mini processor to take on the functions of the computers and to allow a single design to then be propagated among all the installations, so that we would put a little mini processor at each computer, like that, disconnect the 50 kilobit circuits linking the computers themselves, and then interconnect these little mini processors, or IMPs, with the wideband circuits, and interconnect the computers to the IMPs in this fashion. Now, such a network would then operate essentially in the same fashion as the previous one, with this computer talking to this computer by first sending a message to its IMP, having this IMP relay it to this IMP, and this IMP relay it to this IMP, and then this IMP deliver it to the final destination. Now, this kind of a network can be made to be extremely reliable, since an effective control can be placed upon the design of each of these IMPs, since there is no large political problem in getting a large number of sites to cooperate in the design and building of the communications part of the system. Here is an instance of the Arpanet as it was recently configured, as you can see, with some 25 or 30 sites in it. The transmission of a message, say, from a node over here to a node over here might go as follows. The computer at this point would send a message into its local IMP, which would break it down into 1,000-bit packets. The packets would then be transmitted from IMP to IMP along a route selected by the IMPs themselves. At the destination IMP, the packets would be reassembled in the proper order and delivered to the computer. And then a message would go back along perhaps a different route to indicate that the original message was received. The whole transmission cycle typically takes no more than a few tenths of a second. The system is completely independent of the ups and downs of small numbers of lines. For example, if this circuit over here broke in the midst of the transmission, the message had gotten that far, it might then backtrack, go back here, and possibly take some other route until it gets to the destination. In order to add a new resource into the network, such as this, it would get its own IMP and would require 1 or 2 or perhaps 3 connections to other IMPs in the network. That would be all that would be required to effect that connection. So we could, in principle, let's say, get rid of that connection and the network would work, or we could put in that connection over there to add a little more reliability. Let me illustrate such a device down here, which can then be connected into the network. It's nothing more than an IMP, and yet terminal devices, some large number of them, can directly connect to that device.